Okay, so this is the demonstrator for the deliverable 4.7. Here we're using the DSF, it's the disease state fingerprint. So this model was already trained with the NPC cohort, the North Lambert cohort. And we have used 46 years old for the training. So this only contemplate one age of the individuals. Here we have select 5 patients to test this model. In the previous deliverable, in the 2.5 and deliverable 5.4, we have shown the results. And all the models exceeded the 70% of accuracy, even some of them the 80%. So the 6 models that we built were one for the low back pain intensity, and or 5 models each for one of the lumbar levels: L1, L2, L2, L3, L3, L4, L4, L5, L5S1. So here we're going to test 5 patients and check the accuracy. And also the advantage of this tool is that we can see which variable were the most preponderant to define the individual in the control or in the positive group. So if we run this, so we can see the prediction in this case was 75%, considering in this case we only have 4 patients, because this patient, the 990, doesn't have the pain intensity. So the model is also able to escape the individual. So we can see here 4 of these patients. And when we run this, we can see, for example, for the first patient, 7, 8, 9. So these are the variables that were the preponderant to determine the where this individual lives in the DSF space. In this case, the most important were the demographics. So we have the questionnaire here. And for the first one, well, this corresponds to the radiating pain. So it's also useful because well, we are also working with a medical doctor that specializes in the multi-site pain. So you can have pain in different parts of the bodies, and that can influence, for example, the pain in other organs. In this case, well, it's the pain intensity, and we can say that the most important were the radiating, and the other ones correspond to the number 3 and 2 are related, for example, with if the individual smoke, has this smoking condition, also had depression, and they were the most important for the intensity, at least. So the most important were the pain in other side of the body and the habits of the individual, also the psychological threats. So here we can close this, continue with the next one. And now we can see the other patient, what were the most important, and all of them, the most important were if the patient smokes, and the radiating pain, and the daily habits, for example, the disability. So every time that we continue, we can see the most important for each patient. Well, also the second one was vulnerable, where here, for example, the modic changes, also the prolapses. So then we can continue. And now this is the first, now we can continue with the next model. This is for this generation. And now well, all the variables totally change. The most important were the output that we have obtained from the Terence McSweeney's tool. He's also another PhD student for the consortium for this photo. He's calculating these radiomics. So the radiomics were obtained through a post-processing using the MRIs. So here we can see all the most preponderant variables from the radiomics that allow us to differentiate positive and control cases. In this case, well, what I had 100% of precision. Now we have included the patient 990. So if we continue, now we can observe that all of them more or less share the same DSF3, but some of them have some changes. So this is very useful because the DSF is telling us what were the variables that were most preponderant to differentiate between these two groups. So in this case, we can be sure that, for example, this patient doesn't have the degeneration, at least in L1, L2, because these variables. But as you can see, they are different from the other one that in the other case for the pain intensity, the most important were the demographics. And we can continue with that. Of them shared a very similar DSF, radiomics, the most important one, and so on. So and then we can continue with the again the next model that now is for the degeneration of L2, L3. So we can cancel this because more or less all of them share the same disease state fingerprint tree. This is part of the visualization because the DSF is a visualization tool. So now what are we doing is filter all the variables because we have many. So the idea is to only train the model with the most important one and see if we get the same accuracy. We were getting 90% of accuracy with the training model when we perform the test accuracy and also for the validation accuracy. So our idea now is to filter all the variables that are not preponderant. So we can would like to have just a few of these variables. Most of them are questionnaires. So this is how the disease state works, and all the details for the training and the accuracy were submitted in the deliverable 2.5 and 5.4. And this was just a demonstrator of the tool. That again, the advantage is that we can determine where this individual lives in the state space and why was set it in that condition, control positive. Well, thanks.